Hello everyone. In the previous class I have explained how to solve a differential equation, that is both homogeneous and non-homogeneous differential equation, using the method called inverse differential operator method. In this class I am going to explain the next method to solve the differential equation, that is called method of variation of parameter. So method of variation of parameter is a method to solve a differential equation. In the previous method, that is in the inverse differential operator method, to solve a differential equation we have to find the value of yc and yp. For the homogeneous equation we need to find only yc, that is complementary function. For non-homogeneous we have to find both the yc and yp component. In method of variation of parameters we can find the solution of the given differential equation without finding particular integral and using the only complementary function, that is using the complementary function without finding the particular integral. We can find the solution of the given differential equation using the method of variation of parameters. In the previous method, that is in the method of inverse differential operator, we can find the solution of equation with any order. It is a higher order differential equation. We can solve the differential equation with any order, but in this method the differential equation is restricted to degree 2 only. We can solve only the second order differential equation using method of variation of parameters. Here also the first step is common. We have to find complementary function. Using the complementary function without finding particular integral, we can solve the solution of the differential equation. For that, let us consider a differential equation of second order. Since it is restricted to equation of order 2 plus a1 dy by dx plus a2y is equal to phi of x. Based on the obtained differential equation, we get roots, that is case 1 real and distinct roots, real and coincident roots, and case 3 complex root. Based on the obtained root we have to write the complementary function, that is c1 into, based on the root we have to write the function here. In general I will represent that function as y1 plus c2 into y2. First we have to write the obtained complex solution in this form, c1 y1 plus c2 y2. After this, next we have to apply the method of variation of parameters. To apply this method, we have to write the obtained complementary solution as y is equal to, by changing c1, c2 parameters, that constant elements, as a and b, a into y1, b into y2, where a and b are constant elements here and y1, y2 are the functions of the independent variable given in the problem. So in this example we have x as the independent variable, y1, y2 are the functions of x. First we have to write the obtained complementary function in this form, a y1 plus b into y2. So after writing this we have to find a function called Wronskian function. We have to find Wronskian function which is represented by w. We have to find Wronskian function, that is w, which is y1 y2 dash minus y2 y1 dash, or simply we can write this as determinant of y1 y2 y1 dash y2 dash. On expanding this determinant we get the same element. We have to find the Wronskian's element. The solution of the given differential equation is a into y1 b into y2. The remaining part is we have to find the value of these parameters a and b. To find value of a and b we have these following results. A is equal to minus integration of y2 into phi of x by w with respect to x, y2 into phi of x by w with respect to x, and the value of b is equal to integration of y1 into phi of x by w with respect to x. Here both the integrals are indefinite integral. After integration we have to write integral constant as c1 and c2. So after finding a and b, we have to substitute in the equation number 1. Then the obtained equation number 1 is the solution of the given differential equation. So this is the procedure to solve problems using the method of variation of parameters to find the solution of a differential equation. In this method, we find only the complementary function without finding particular integral. Using this procedure, we have to find the solution. So we are first step, we have to write the obtained complementary function as a into y1 plus b into y2. This y1, y2 obtained based on the roots of the equation. After writing the equation in this form, represent that as 1. After taking equation number 1, find the Ranskin function, that is y1 y2 dash minus y2 y1 dash. After getting w, find the value of the parameters a and b using this result and substitute the value of a and b in 1 to get the complete solution. Sir, ಸರ್ ಇದ್ರ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ ಮಾಡಬೇಕು, ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಆಯಿತು. Let us solve some problems on method of variation of parameters. First problem is y double dash plus a square y is equal to secant ax. So it is second order differential equation. So this equation can be written as, let y double dash can be written as d square plus a square y is equal to secant ax is the given equation. To write the solution using variation of parameter method, first we have to find the complementary function. That is, to find the complementary function, auxiliary equation is m square plus a square is equal to 0. From this, root is m square is equal to minus a square, m is equal to root of minus a, which is equal to plus or minus, since we have square root of a square, that is a, root of minus 1 is plus or minus I, we get plus or minus ai, which is a complex root. Therefore yc is equal to c1 e power of 0x here, hence the real term is 0, which is equal to 1 c1 cos ax plus c2 sin ax. This is the complementary solution. After getting complementary solution, we have to write the obtained equation in the form of y is equal to a into y1 plus b into y2. In this problem, e power of 0x is equal to 1. We left with c1 cos ax, c2 sin ax. We are changing the parameters c1, c2 as a and b, where y1 is equal to the function cos ax. y1 is equal to cos ax here, y2 is equal to sin ax. So the complete solution of this equation using variation of parameter method is a y1 b y2. The remaining part is we have to find the value of a and b and we have to replace that. For that, we have to find the Ranskin identity, which is represented by w, and the expansion is y1 y2 dash minus y2 into y1 dash. As I already explained, after getting y1 y2, we have to identify Ranskin identity using the formula y1 y2 dash minus y2 into y1 dash. From the above result, y1 is equal to cos ax into, next term we have y2 dash. y2 dash is differentiation of y2. y2 is equal to sin ax. Differentiation of y2 is cos ax into a. Cos ax into a minus y2. y2 value is sin ax, that is sin ax into y1 dash is equal to differentiation of y1. Differentiation of cos is minus sin ax into differentiation of ax is equal to a. Simplifying this, w is equal to a is common term in both the element into cos square ax minus of minus plus sin square ax, and the value of cos square plus sin square is a standard result, which is equal to 1. So we get a into 1, which is equal to a. So the value of w is equal to a. So now to find the value of a formula is minus integration of y2 into phi of x by w with respect to x, and the value of b is equal to integration of y1 phi of x by w with respect to x. Substitute all these values. A is equal to minus, what is the value of y2? Y2 is sin ax into, what is the value of phi of x? Phi of x value were given here, secant ax divided by the value of w is equal to a with respect to x. Similarly, in b term, y1 is cos ax and phi of x is secant ax by a, that is w value with respect to x. Now we have to integrate these two functions. So observe here, to integrate we have product of two functions. Directly we can't integrate this because we have sine into secant. Both are special functions here. It is not possible to apply product rule also. That's why we have to alter this using trigonometric identities. We know that the value of secant can be written as 1 by cos. Here also secant can be written as 1 by cos. Applying that result, so the value of a, that is the value of a is equal to, we have minus, this a is the constant term, minus 1 by a, integration of, writing sin ax as it is, secant ax can be written as 1 over cos ax. Secant can be written as 1 over cos ax with respect to x, and b can be written as, again 1 over a is the constant term, cos ax into secant is 1 by cos ax with respect to x, and the value of cos ax get cancelled, then p is equal to 1 by a, the remaining element is 1 here, and integration of 1 is equal to x plus integral constant. So since this is the second term, I will write integral constant as c2. Now for the first term, we have a is equal to minus 1 by a sin by cos. The value of sin by cos is tan ax with respect to x. Then a is equal to minus 1 by a, integration of tan x is log of secant ax. Integration of tan is log of secant ax by a plus integral constant equal to c1. So therefore the value of a is equal to log minus log of secant ax minus log of secant ax by a into a square plus c1. So this is the value of the parameter a and this is the value of p. So therefore to get solution we have to substitute the obtained a and b in equation number 1, that is a into y1 plus b into y2. The value of a is equal to minus log of secant ax divided by a square plus c1. This is a into y1. What is the value of y1? That is cos ax plus b value. B value is x by a plus c2 into y2 value, that is equal to sin ax. The value of y2 is equal to sin ax. So this is the result. Or we can simplify one more step, that is y is equal to split the element, first factor into cos ax, second factor into cos ax, again in the second term first factor into sin ax, second factor into sin ax. First I will write the constant element first, that is c1 into cos ax, c1 into cos ax plus second term c2 into sin ax, c1 into cos ax plus c2 into sin ax. Next the first element of the first term, that is minus log of secant ax by a square into cos ax plus plus x by a into sin ax. So this is the obtained solution of the given differential equation using the method of variation of parameters. In this method just we need to find complementary function. After that we have to write that in the form of a in y1 plus b y2, and then identify the two functions y1 y2, then find the Ranskin function, that is w, which is equal to y1 y2 dash minus y2 y1 dash. Then using the w find the value of eb and substitute in the equation number 1 to get the complete solution of the given equation. Let us take one more problem on variation of parameter method, that is d square y by dx square minus 2 dy by dx plus y is equal to e power x divided by x. To apply the method of variation of parameters, first we have to find the complementary solution. For that, let us write the given equation in terms of differential operator method. The second derivative can be written as d square minus 2d plus 1 of y is equal to e power x divided by x. So this is the value of phi of x here. To find the complementary solution, let us find the auxiliary equation, that is m square minus 2m plus 1 equal to 0. So solving this, so this in the standard form a square minus 2ab plus b square, where a is equal to m, b is equal to 1, that can be written as m minus 1 whole square. For this we have two factors, m minus 1 into m minus 1 equal to 0, then m roots are plus 1 comma 1. Plus 1 comma 1 is the real and coincident root. We have equal roots here. For equal roots, the complementary solution is c1 plus c2x into the obtained root is e to the power of 1x. To apply the method of variation of parameter, we have to write the given equation in the form of y is equal to, we have to write the obtained complementary solution in the form of ay1 plus by2, but this equation is not in that form. For that, re-alter this by multiplying c1 into e power x plus c2 into x into e power x. By combining these two equations, let us take this as equation number 1. This is the complete solution after getting the values of a and b. Comparing these two, the value of a is equal to c1, the value of y1 is equal to e to the power of x here, and the value of y2 is equal to x into e to the power of x. Then we have to find the Ranskin identity, that is w. W is equal to y1 y2 dash minus y2 into derivative of y1. y1 y2 derivative minus y2 into y1 derivative, which is equal to, what is the value of y1 here? That is e power x. And next we have derivative of y2. We need this y2 derivative. The value of y2 is equal to x into e power x, which is a product of two functions. Hence, differentiating this, y2 dash is equal to first term x, differentiation of e power x is e power x, plus second term writing as it is, differentiation of x is equal to 1. Differentiation of y1 is just e to the power of x. y1 writing as it is, y2 dash is x into e power x plus e power x minus y2. y2 value is x into e power x into y1 dash is e to the power of x. Simplifying the obtained result, w is equal to x into e power x is e power of 2x plus again e power x into e power x, e power of 2x minus x into e power of 2x, where minus x e power of 2x plus x e power of 2x get cancelled. The remaining term is plus e to the power of 2x. The obtained element is plus e power of 2x is the value of w. Next we need to find the values of a and b. So what is the result for a? A is equal to minus integral y2 into phi of x by w with respect to x, and b is equal to integration of y1 into phi of x by w with respect to x. Substitute the values. A is equal to minus, what is y2? y2 is equal to x into e power x. x into e power x. Phi of x is there in the given problem, e power x divided by x whole divided by w. W is equal to e power of 2x with respect to x, and the value of w is equal to y1, that is e power x. Phi of x is e power x divided by x whole divided by w value is e power of 2x. In the numerator we have e power x into e power x, which is equal to e power of 2x, and this e power of 2x get cancelled. In the second term, again also here also we have e power of 2x, e power of 2x get cancelled, and the value of x and x also get cancelled. In the first term, the remaining element is minus 1 with respect to x. So integrating this, minus integration of 1 is x plus integral constant is c1. The value of a is minus x plus c1. In the same way, the value of b is, what is remaining here, 1 by x with respect to x, and the value of integration of 1 by x is log x plus c2 is the integral constant. Therefore, substituting obtained a and b in equation number 1, y is equal to a into y1. We have a value is minus x plus c1 into y1 value is e to the power x plus b value, that is log x plus c2 into y2, that is x into e power of value e power of x. So this is the solution. Or we can simplify one more step. Y is equal to, first writing the constant element c1 e power x, constant element in the second term c2 x e power x, remaining element minus x into e power x plus x e power x into log x. So this is the solution of the given differential equation of second order with phi of x is equal to e power x by x.